Hi there. This is a first in a five-part series on IDT's new full-featured PCIe clock family. The first part of the series will be a family overview. There will also be a part on the clock generators, another section covering the clock buffers, a fourth section that will deal with the clock multiplexers, and finally a fifth section covering some of the applications for the full-featured PCIe clocks. So let's jump right into the family overview. So PCI Express is evolving. There are two major things happening in PCI Express these days. One is the PCIe Gen 4 specification is moving toward the 0.9 drafts stage. And Gen 4 is going to bring 16 gigabit per second data transfers to the architecture or to the PCI Express world. And then there's also going to be two new architectures which are supported in a non-specific way. The two architectures are the separate reference no spread or SRNS and the separate reference independent spread or SRIS clock architectures. These are going to be supported in the PCI Express Gen 4 specification, but there will be no explicit specifications on the reference clocks. So what the phrase is that SRNS and SRIS clocking will be implementation dependent. And what that means is that there's not going to be an explicit reference clock jitter specification, and that means that IDT we'll need to work with the SoC vendors to ensure interoperability. And regardless of whether there's an explicit specification or not, IDT delivers solutions for these architectures and increasing performance requirements, and we have always done so. So in terms of the IDT's PCIe clock families, there are three major families. The focus of this series of presentations is on the full-featured PCIe, which you see on the left of your screen. We've just introduced the new L series parts to production, which are the 3.3 volt devices that have the best performance, PCI Gen 1 through 4, and also SRNS and SRIS support. And those follow the very successful 1.8 volt V series and the 1.5 volt U series parts, which have been in the market for a couple of years, supporting Gen 1 through 3. The other specs and the Gen 4 common clock spec are being evaluated against these parts to see if they will be able to do Gen 4 or not, and so those other specs are TBD. The other family that we have is the Phi clock family, which is Phi clock plus PCIe in this case, where we add some less than 300 femtosecond RMS high-performance SerDes clocks or Phi clocks, and then also provide some PCI Express Gen 1 through 4 clocks. Then the last family is when you really need to go smaller and you don't need all the features, you want a simpler board layout, and you have very tight space constraints, is the micro PCIe family, which will be the subject of another presentation. And we're defining smaller, as in micro PCIe, as any device that is in a 3x3 millimeter or smaller package. So the common features of IDT's full-featured PCIe family are as follows. You have an output enable pin for every PCIe clock. You have spread spectrum clocking capability and compatibility across every part in the family. On the clock generators, there is a reference output which can save you an XO in your system. And then to make it really simple to use the parts, you have on the clock generators, you have pin control of 3 different spread amounts, including spread off. And you also have on the zero delay buffers pin control of the PLL bandwidth, whether you want it to be high bandwidth, low bandwidth, or the PLL bypassed. That is all done from a single pin. The other common feature is multiple pin selectable SM bus addresses. So the clock generators have a choice of 2 SM bus addresses. The buffers have a choice of 3 SM bus addresses, and those 5 addresses do not overlap. So you can have up to 5 of these devices on a single SM bus segment. The other common feature is that we use low power, and some people refer to this as push-pull, but we use low power HCSL outputs on all of the parts, and they are offered with a choice of 100 ohm integrated terminations or 85 ohm integrated terminations. And all the parts in the full featured family are between 2.5 millimeters by 2.5 millimeters up to 6 millimeters by 6 millimeters. They all offer iTemp operation, and the most power consuming part consumes 211 milliwatts. So they're very power efficient. So the 3.3 volt full featured PCIe clock family, which is the newest one, provides the basic functions you need for clocking, provides a clock generator function, provides both zero delay and fan out buffers, and provides a clock muxing function. And the muxes are 2 inputs with different numbers of outputs. In the 3.3 volt family, it's a 2 input and 4 output mux. So the family has performance. The 3.3 volt family is PCIe Gen 1, 2, 3, 4 common clocked compliant. Also supports the SRNS and SRIS architectures. You've got flexibility in the family where you can right size the part for your design because we provide from 2 to 9 outputs. Again, the 3.3 volt family does allow factory OTP customization if you have a particular setting that you would like to adjust, whether it's slew rate, output impedance, polarity of control signals, or even on the clock generators, maybe you prefer to run from a 20 megahertz or a 24 megahertz reference clock instead of 25. That can easily be OTP'd into the parts. We also have easy AC coupling to other logic standards such as LVPECL, LVDS, and CML. There's SM bus programmability for the signal integrity and functionality, and again, that can be OTP customized for your particular needs. And then we have 1.5 and 1.8 volt versions of the parts available for the more power conscious applications that might be out there. As far as 3.3 volt size and power, this family ranges from a 4x4 millimeter at the smallest end to a 6x6 millimeter QFN in the largest part. These save up to 53% board area compared to IDT's legacy 3.3 volt current mode devices such as a 9DB803 for instance. The integrated terminations allow you to save up to 36 resistors, and that 36 resistors represents 62 square millimeters of board area. So really great for space constrained designs. And then power wise, the low power HCSL outputs allow up to an 80% power savings with the 3.3 volt parts. If you can use 1.5 or 1.8 in your design, you can save even more power. The parts are easy to use because, as shown earlier, the basic functions are controlled by hardware pins, so you do not need to use the SM bus for most applications. And we do have the individual OE pin on each PCIe output. So the 3.3 volt full-featured PCIe clocks support Gen 1, 2, 3, 4, common clock, SRIS, and SRNS. It is a family of parts with the clock generator, fan-out buffers, zero delay buffers, and clock multiplexers, and it supports both 100 ohm environments and 85 ohm environments without any external components. The numbering scheme is really easy. All parts start with a 9. And if you're looking for a generator, it's a 9FG. The FG stands for frequency generator, actually. If you're looking for a buffer, it's 9dB for differential buffer. And if you're looking for a mux, it's a 9dm for differential mux. And then the operating voltage is the fourth character in the part number. L is is for 3.3 volts, which stands for low power. The V indicates 1.8 volts or very low power, and then the U indicates 1.5 volts or ultra low power. The next two digits then provide the number of PCIe clock output pairs. So ranging from 1 all the way up to 9 currently. So that's the number of outputs. And then finally, the next to last digit indicates the output impedance. So a 33 ohm output impedance would have a 3 as the next to last digit. And then the device variant would be like 31, 32, 33, 34, etc. 100 ohm output impedance has the next to last digit as a 4. And you would have 41, 42, 43, 44, etc. And then finally, the 85 ohm output impedance starts with a 5, and that would be like 51, 52, 53, etc. That's it for the PCI Express family overview. Thank you for watching.